Trigonometry, Chapter 3, Radian Measure and the Unit Circle. Section 1, Radian Measure. Video 5, Evaluating Trig Functions at Radian Measures. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous video, we focused on very specific radian measures that, if memorized, can make converting between degrees and radians automatic for special angles. In this video, we revisit trig functions and discuss evaluating them when the angle used is in radians. Spoiler alert, nothing really changes. Question: how would we evaluate a trig function when the input is in radians? For example, how would we evaluate tangent of 2 pi over 3? Think about that. Think about what we know and what we want to know. Well, if you were thinking convert to degrees, you're not wrong. Although memorizing trig functions of radian measures is ideal, there's nothing wrong with converting the angle to degrees and evaluating trig functions as we've done previously. So let's do that as we evaluate tangent of 2 pi over 3. Now, if we're going to convert this to degrees, it would be convenient to know what pi over 3 radians is in degrees. Do you remember? First, let's convert the angle to degrees by using the equivalence pi over 3 radians equals 60 degrees. So 2 pi over 3 is 2 times pi over 3, which is 2 times 60 degrees, which is 120 degrees, which can be done quickly if you remember that pi over 3 radians is 60 degrees. Now, since 2 pi over 3 radians equals 120 degrees, then tangent of 2 pi over 3 in radians is equal to tangent of 120 degrees. So now we focus on tangent of 120 degrees. We're going to use quadrants, reference angles, and special triangles like we've done before. First, 120 degrees is in quadrant 2. So tangent of 120 will be negative because in quadrant 2, only sine and its reciprocal are positive. Next, let's place the 120 degree angle in quadrant 2, standard position, and measure its reference angle. For angles between 90 and 180, the reference angle is calculated by subtracting the angle from 180. In other words, we need to measure this angle here, but altogether this is 180, so the missing reference angle is 180 minus 120, which is 60 degrees. Now, using the sine, negative, and the reference angle, 60 degrees, we get tangent of 120 degrees equals negative tangent of 60 degrees. And we can use the 30, 60, 90 triangle to evaluate tangent of 60 degrees. It's opposite over adjacent, so it ends up being square root of 3 over 1 with the negative in front, getting us a final answer of negative square root of 3. Therefore, tangent of 2 pi over 3 equals negative square root of 3. So turn it into degrees and do what we've done already. Let's try it again with sine of negative 3 pi over 2. Let's think about it for a second. Pi over 2, how many radians is that? And what is negative 3 times that? And how do I do sine at that angle? Well, pi over 2 is 90 degrees. So negative 3 pi over 2 is negative 3 times pi over 2, which of course is negative 3 times 90 degrees, which is negative 270. So this is a quadrantal angle. It's a 3/4 revolution clockwise. And as a consequence, it puts us up on the positive y-axis. Having trouble seeing that, then quickly draw something like this. Y-axis, x-axis, negative 90, negative 180, negative 270. So we are on the positive y-axis. So to evaluate it, we only need any point on the terminal side. Since we're up here, let's pick the point 0, 1, and let's run with it. At the point 0, 1, r is equal to 1. Remember, r is the distance from the origin, so it's 1, and y is equal to 1. This means that sine of negative 270 degrees is y over r, which is 1 over 1, which is 1. Therefore, sine of negative 3 pi over 2 is also 1. It's all coming together. Now you try. Pause the video and try the following. Evaluate the following trig functions at the radian measures. You get a refill. All right, here's your fair warning if you haven't paused the video yet. Solutions in 3, 2, and 1. Did you catch that cotangent of negative pi was undefined? Remember, some trig functions are undefined when the denominators in their definitions end up being 0.